Today is one day that I'm privileged to talk to you guys about AWS production infrastructure setup. So basically, we'll be talking a lot on the planning side and on the architectural design side. Yeah, so information about me is my name is Moses Nandwa. I am a software engineer at Safaricom. I started out as an intern, worked with several projects, doing several things. PHP at one point. Currently, I do a lot of Java. And during my career over there, we've done several things, or I've done several things, some of which include system design and also cloud deployment, cloud design, such kinds of stuff. So that's me. Currently, I'm a tech lead of a product that is going to be launched in a couple of months that I'm really excited for. And yeah, so today I'll be giving basically my learnings that I've learned from setting up and using AWS. So this is a question that happens. So we all are developers, or we have at one point developed software applications at one point. I don't know whether my whole screen is visible without this bubble around here on the side.
Yes, it's visible.
Okay. So after software development and testing, what next? We need to find a way to ship the software to our developers. And it's in our best interest that we give the people who are consuming our software, software that is available at all times, minimal downtimes, software that scales. And at the end of it all, we are programmers. There's one thing that we say: we strive to be lazy. We want to offload off all the work that we do to something or somebody else. So because of that, we come up with several things. And in the things that we do, some of them include migration to the cloud, because at times there are many advantages of going to the cloud as compared to working on premise. Also, there are also advantages of different clouds compared to each other, which I'll not engage in today. That's a different kind of conversation that we'll have. Today, we'll just dwell on AWS and speak about it. So one of the things that people fail to do is they fail to plan. So Benjamin Franklin said, by failing to plan, you're planning to fail. So going to the cloud requires a strategy by itself. It's something that you need to plan for in advance. It's something that you need to know what you're going to do over there. It's not something that you wake up today and decide you're going to do it and just do it immediately. It's something that you need to think about, something that you need to probably plan properly about it. So this involves many things. Checking out the options that are available. So we have various options where you can deploy your code. We have cloud, we have colocation, we have on-premise, and we have hybrid. So just to explain, on cloud, we have providers like AWS, Google Cloud, we have Azure, we have DigitalOcean, we have those people. What's colocation? Colocation, you could say, is a strategy where companies build their infrastructure in other people's data centers. So for example, I would have a company and instead of building my own data center from scratch, I would just migrate my servers and racks and everything to that place. And we would have the software run from there, and all the maintenance and stuff like that will be something that will be agreed upon by the person who provides the space for the same. So it's more or less like on-premise, but offloading some of your responsibility to the other person. Then on-premise, we have this setup whereby you have everything running in your data center. You manage everything, including from the start, including power, the server location, security of the physical place, installation of software, and everything that is required to make the stuff work. Power management, everything that goes into making a data center run well. Then we have hybrid, and hybrid can come in various ways, whereby people can be having a cloud setup, and then we would have integration to maybe a data center that is inside on premise for various reasons. We've seen governments being really hesitant to migrate their data to the cloud because of the area jurisdiction. For example, countries will say that they do not want their data stored in a country that is foreign, that they don't have relations with. So that's part of the reason why you might see people having on-premise setups. Part of the reasons why people have hybrid setups, speaking in our case, is we have core systems that run inside our data centers. And this is like an executive decision to have them run there no matter what happens. So that such situations is what makes people have hybrid setups where we have some services running on the cloud and others running on premise. Next, so what would make you to go to the cloud as opposed to just staying where you are right now? So one, it's cost savings. So you tend to save a lot in terms of, first of all, the money that you need to buy the hardware first, the licenses that you need to buy for the operating systems, the people you need to pay to manage your infrastructure, security, and all that stuff. There's better scalability and flexibility in that on cloud, you're able to provision anything, almost anything at the go, and be able to add it to your system. And it works almost immediately, depending on how, again, you set up your things. There's improved networks performance. Data centers that are on the cloud are known to implement cutting-edge technologies. So they tend to have faster networks inside the data centers themselves. There's, again, data security, which is something that is very debatable over here. Your data is likely secure, more secure than when you have your data on premise, in that, first of all, the data centers are protected well from physical access. Again, there are various access mechanisms that are put by the cloud providers to ensure that your data is put well. Then you have the ability to try before buying. In the case of AWS, we have things like, we have this free package, the free tier, whereby you are able to try some of these services, know how they perform before you actually opt into using those products. So that is some of the advantages or things that would make you go to the cloud as opposed to staying here. And something on costs, as I would, sorry, let me hang up. Something on cost that makes cloud really cheap compared to other things is they leverage their massive bargaining power in that, one, they are able to provision or to buy software at scale. They're able to look into other things that will make it easy. They are able to maximize the economies of scale that makes them more affordable compared to things like colocation or maybe running your data centers on premise. So when you're going to the cloud, or when you want to come up with an overall cloud design, there are several things that you need to check out. So first of all is one, security, one, cost, again, cost, high availability, scaling, and latency. These are just some of the points that I want us to look at, but then again, I'll sum them up at towards the end of this thing into what happens. So what do you want to do when you get to the cloud? Like, how do you want your security to be? What are the things that you're supposed to do so that you ensure that your application and your infrastructure is safe on the cloud? So one, we start with access management. On AWS, we have access management. It's known as AIM. And what it does, it's basically a place where you could use to assign people roles, policies, and various things that we'll use to determine what a person can access and what another person cannot access. So for example, if I am a developer, I have no business seeing billing. If I am a developer, for example, if your case is advanced, I have no business checking out or provisioning servers. If, for example, I do system administration, I have no access to billing, and such kinds of things. Next thing is your network security. What kind of traffic do you want to allow where? I mean, Do you want traffic in your VPCs to be accessible by everyone? Do you want your databases accessible by anyone? Do you want your app servers accessible by anyone? How do you talk to partner systems, maybe through VPNs, through direct connect and stuff like that? How do you take care of that? Then there is security for infrastructure. This is, in this case, I'd like to identify servers and DBs. How do you manage access to them? Who can SSH to a given server, and from where can they access to a certain server? Such kind of things is something that you want to look at. Then something else is your data security. When a hacker wants to compromise a system, he normally looks at what they can gain from it. So what do you look at over here? The person will try and intercept data that is in transit, and maybe we'll try to access data that is at rest, maybe your logs, your databases, your caches, and stuff like that. So do you have a setup that will facilitate all these? Yeah, so just going deeper, we'll look at this AWS shared responsibility model, which I'll share the link at the end of the call. And basically what you see over here is two things. There's a blue side and there's the orange side. So the blue side is the customer's responsibility, and the orange side is the responsibility of AWS. So AWS does a significant chunk of the work, especially comparing to things like having your data center running on premise or something like that. AWS just takes some of the load from you. So for example, things like security in your regions, availability zones is not particularly security, but also ensuring that things are available at that time. So is your hardware safe? Is it available? There's your compute, storage, and networks. Are they well configured? Are they available? Then there's standard software that is there that's supposed to run. Is it available? Is it safe? Then going up towards the customer side, there's several things that the customer is now responsible of. So the customer data that you ingest, you are totally responsible of how you store and how you transmit it. Platform, applications, identity, and access management, you're definitely in charge of them. So for example, if I installed a version of Docker in a VM that was given to me by AWS, I am solely responsible for that. I am responsible for who accesses that server. That lies within me. Things like firewall configuration, operating systems, networks, network security, updating and patching of the same, that's my responsibility. And then there's things that I'll mention maybe heavily is the encryption. So client-side data encryption, data integrity and authentication, server-side encryption, network management, so encryption, can't see this very well. The last point over here on network traffic, you're totally responsible for that. So that's the AWS shared responsibility model. And from here, we can see what we need to do, like which responsibilities do we have? So going to the next thing, which I'll say is cost, I'd like to say this, that the cloud is more or less like a very nice hotel that has everything in place. So you'd go to that hotel, you'd order that food, the waiter will not ask you whether you have money or not, but at the end of the day, you'll be presented with a bill. And by the way, anyone can order anything on cloud, and at times this can get really catastrophic, especially if you don't have these things in order. So you might be surprised by a very high bill if you don't take care, if you just provision stuff with you. So what goes into getting maybe that high bill or maybe that bill that is optimized? So one, your service selection just says a lot. If, for example, you're going to select something like, let me put it this way. If you're going to select a VM that is a certain size compared to another, that will highly influence the bill that you'll get. If you're going to select one queuing mechanism as opposed to another, or if you're going to select maybe a partner or we have some of these things that we call services provided by partners. For example, if you're connecting to, you want to create a VPN, you order something from Cisco, that's probably going to be expensive compared to maybe what AWS is offering and stuff like that. That will make, might influence how your bill will look like. So your resource utilization, the services that you're charged for, how much you use. So for example, if you're going to order something like Lambda functions, Lambda function, you're charged by what, by how much traffic you bring in. So depending on the traffic you bring in is how you'll get charged. So that goes into one of the things that makes the cloud to be expensive or cheap. And then your operational efficiency. I think I'll explain that a bit later. So several things. Another thing that you might look at is from the systems that you build, what logs and matrices are you able to get or are you generating? So in your application, how are you logging things and what is the nature of verbosity? So there's information like API keys, the customer KYC, the response bodies, and the response bodies from external systems. Those should not be logged. The other thing is, what matrices are you collecting? And again, once you collect those matrices, what are you using these matrices for? So for example, I would say you're collecting matrices about maybe what's the response time? What's the average response time you're getting, say from a load balance or something like that? What can you use that information from? That can be used for maybe proactive monitoring or something of the sort, or maybe triggering of events. So there's another thing that we need to look at, which is scaling, or you need to consider scaling. And scaling is basically how your infrastructure adapts to the load, how it scales up to accommodate many users and how it scales in when the traffic goes down. So how well can your infrastructure scale? Is it effortless? That's something that you need to consider when designing a good system or designing your architecture on the cloud. The next thing is operational efficiency. So how are you able to do things? How are you able to do day-to-day tasks on the cloud? So for example, how are you able to provision infrastructure? If today I say a server was needed, or I needed to create the whole environment again, how do I do it? If today a developer came in, wrote code and needed to deploy that code to production or to deploy it to a certain environment, how do they go about it? So in case there is, the third point is root cause analysis. In case there was a downtime or there was a failure or something like that, how do you get to the bottom of the matter? How do you know what specific thing caused that problem to happen? And how are you able to like maybe do a replay of the same and mitigate that thing from happening in future? So that's operational efficiency. And all these things that I've talked about, they come into something that AWS has, and it's called the well-architected framework. And in the well-architected framework, there are 5 pillars. So the 5 pillars are basically security, cost optimization, reliability, performance efficiency, and operation excellence. So one,
one million, it's 2000.
Yes.
No.
Oh.
Let's just find the person and we mute. I think.
Okay.
Can you mute Sarafina? Sarafina, can you mute yourself?
All right.
Okay. I think Moses, you can mute him. You can mute her.
Okay, just a second. I'd like to exit fast.
Just mute her.
Oops.
Just a second.
Oh.
You need to see everyone.
I think Amanda or something like that. She's not in the call anymore. Oh, just proceed. Sorry for that. Just proceed, guys. Please, when you join, just mute yourself.
Okay.
So just proceed.
Okay. So, guys, are you able to see my screen again? I've resumed sharing.
Yes.
Just put this away. All these things that we've talked about add up to something that we call the well-architected framework, which is something that is trademarked under AWS. And I'd like us to discuss this diagram that you see here briefly. So under the first pillar, we have security. The next one is cost optimization, reliability, performance efficiency, and next, operational excellence. So under security, we have several things that we'll look at. I'll try and go through them one by one. And the first thing is identity and key management. So basically, how do you identify users, and how do you manage to authorize them? That's how we talk about identity. How do people access the AWS platform that you have, and what permissions do they have? That's identity and key management. Next is encryption. Encryption is basically one of the most important things that you'll ever see on the cloud, and one of the things that you need to consider when building and even designing your systems. In that one, encryption, you need to, first of all, encrypt every data that is in storage and even on transit. The next thing is, how do you do your security monitoring and logging? Next, do you have dedicated instances? In this case, for example, let's say in case somebody wanted to access a server or something like that, technically it should not be possible for them to do that. They should have instances that are set up for the same thing. How are you complying to the laws that are there? For example, like if your country says that certain data like health data or certain data cannot be kept in a public cloud, how are you dealing with that? Something to say is that even though these things are there, over the past, from the talks that we've had and things I've seen AWS do, is that they have moved to work with governments and other providers to give them solutions that have enabled them to build or even store their data on the cloud. So another thing is governance. How do you do things like change management and stuff like that? Other things that maybe a company or corporates might need. The next pillar is cost optimization. So under cost optimization, there's reserved instances and spot instances. Try and use them by all means. Volume tuning. What kind of volumes are you using for your storage? The service selection. What service do you choose? What preference do you have? Do you have preference of using maybe EC2s compared to maybe using images deployed on Docker containers running on ECS, or maybe Lambda functions or other things? What service selection do you choose? In terms of consolidated billing, so AWS offers you a mechanism whereby you could have a setup of maybe child and peer accounts that are maybe managed by a parent account, and maybe the bill is sent to the parent account. So do you have that setup? How do you use your resources? What level of utilization of resources do you have? Do you have just big servers that you're not utilizing them fully? You know, that's an extra cost that you could maybe mitigate by ordering small machines and maybe scaling when something happens. How do you commission VMs that you're not using? How do you commission like databases that you're not using? That's something that might either improve or reduce your cost. Then there's reliability. Are you pushing your service towards the limit? So in your design, there are limits that are set. For example, you cannot order a certain number of VPCs. Maybe a subnet cannot contain a minimum of these, or a subnet, a maximum number of IPs. Another thing is, how reliable are you? For example, looking at from where we are, if you're offering a product to maybe many nations in the world, how is your setup equipped for the same? Do we have latencies between different data centers and stuff like that? How do you scale. For example, if the traffic increases, how is your application able to handle that? Are you able to scale? Are you able to provide the customer with a seamless experience by maybe scaling horizontally or vertically in your applications? Next thing is, how do you do your health checks? How do you do your monitoring? How do you know whether your service is up or running? How do you maybe reinstate it if it's down? Yeah, something of the sort. How is your network set up? Is it reliable? Are you going to one day start scaling and you find that you've reached the maximum number of IPs? Finally, we have disaster and self-healing. So for example, if a pod goes down in Kubernetes, or if a service goes down in one of your servers, are you able to reprovision it again? The fourth pillar is performance efficiency. This is basically improving how your app performs. So one, are you using the right services? Are you using, for example, if we talk about VMs, are you using VMs that are optimized for, if for example, you are doing tasks like, hold on, if you're doing compute intensive tasks, are you using VMs that are optimized for compute, or are you using VMs that are optimized for storage? What's your storage architecture like? Are you using block storage? Are you using, what forms of storage are you using? Are you using solid state drives? Are you just using ordinary hard drives? What utilizations, resource utilizations are you using? How much RAM are you using? How much network are you using for your network processing, for your network transfers? And then the next thing is caching. Caching is basically where you put things like media and other things that are frequently accessed by your website in maybe a region that is close to somebody. Caching is whereby maybe you could introduce things like Redis to manage read tasks easily so that the APIs can perform faster. How are you handling that? There's the latency requirements, under which maybe you could see which zone can a customer connect so that they can be able to ping your service faster. And then there's planning and benchmarking. Under that, I'll just pause for a while. There's operational excellence. Under operational excellence is now, this is basically define what your day will look like. Once you provision the servers, or once you're provisioning the servers, how do you go about with your day-to-day activities? So how are you able to do your continuous integration and continuous deployment? How are you able to deploy your software there? Are you able to test it and stuff like that? So the next thing is basically things like, they basically fall under infrastructure as code. Are you able to provision your infrastructure on the go? So if today we decided that we are going to tear down our software and maybe our infrastructure and maybe reprovision it again, are we able to reprovision it again? So, and then there's the last part that I'll talk about, which is the root cause analysis, maybe seeing what happened. I've talked about it in the last slide, I believe, whereby if you have a bug or if you have a downtime, you're able to trace back to what caused the downtime or what caused the failure, maybe replay it and maybe make a fix that will make it not appear again. So that's basically what the well-architected framework contains. I've tried to summarize it in the smallest time that I have, but again, at the end of the slide, I have links to it that once I share the slides, you guys can go and look at it in detail. Now over here, we have a sample setup of something that one might want to run on the cloud. And I'll just go through it right now. I don't know whether it's visible to everyone clearly.
Yes, it is.
Okay. So over here, I'll not go again to the basics of what AWS has, but I'll just mention several things about what maybe a good app looks like, or maybe a good setup looks like. This is not the ultimate setup, but it's a setup that incorporates some of the best practices that I have learned over time. So just allow me to move from this screen and project a file that maybe I can point to. A second. Yeah. So is this visible properly?
Yeah, it's good.
Okay. So AWS has many regions. So when you let me just start it over again. When you start with your journey with AWS, the first thing that you need to identify is what is the nearest region to your location. So for example, people like us who are in Kenya, we do not have any data center, AWS data center that is available to us. So as a result, we need to find a location that is near us so that we can deploy software there and have the smallest latency between our users and our infrastructure that is over there. So what you see over here as the blue border is basically an AWS region. Mpaka hapo tuko sawa? Or are we okay with that? I talk a lot of Kiswahili sana, so tutaelewana. So inside a region, we have things called VPCs, which are virtual private clouds, and basically virtual private clouds is we could say like it's a cloud within a cloud that allows you. It's a cloud in a region that allows you to do several things. For example, think of it this way: if you are doing a data center, you'd put a region that would be mainly handling things like application servers. You'd have another region that would deal with your databases, storage and cache and stuff like that. You'd have another region for the same. And maybe you'd have another place whereby external partners would connect to it. And that's what we see available over here. So inside a place like, inside the VPC, a VPC spans across availability zones. So how I'd put it this way, if today AWS came to Kenya, they would probably set up an availability zone in Nairobi, another one in Mombasa, and say another one in a totally different geographical area that cannot be affected by calamities like, say, earthquakes, storms, and stuff like that. They are very separated, connected to different power grids, and in case one subnet goes down, the other ones are always there for high availability. So if you look keenly, we have 3 availability zones available over here. So taking a case like Ireland, EU West 1 or EU West 2, it has zone 1, zone 2, and zone 3, whereby zone 1, zone 2, and 3 are totally different geographical areas and are highly less, very likely, not likely to go down at the same time. So the reason why we do this and we provision infrastructure in all the availability zones is that, one, we do not want a situation whereby a data center goes down and your infrastructure is not available. That's why we provision infrastructure in all availability zones. So under here we have 3 subnets, which are public. One subnet under every availability zone, and then the choice of my computing needs is Kubernetes for several other reasons that maybe we might talk about after this call or maybe another time when it's set up. You have Kubernetes that runs across. Of course, Kubernetes is exposed to maybe the APIs by something that is called an ingress load balancer, which is essentially an application load balancer. Under here, next to it, I'll just move next so that I finish with what is below. We have our VPC, with, again, 3 different availability zones. And notice these are private subnets, so they are not accessible from the internet, and people who don't have access to them cannot talk to them. So here is where we put our things like databases, caching, and queues. So we can have our RDS, Relational Database Service. We can have DocumentDB. We can have Elastic Cache, where we have like Redis. We can have Amazon MQ and Amazon Managed Kafka. So for of course, our streaming options. Then to connect the two, we use VPC pairing, whereby we say that these subnets should talk to this subnet. And again, remember to only allow the traffic that you need. For example, if you're going to talk to this one, you only allow, say if your DB is MySQL, runs on port 3306, only allow traffic from a certain, from this VPC to this one, from this VPC to this VPC on the given port. Then the final one is we have the VPC that deals with external connectivity, whereby we've seen people who work with various banks and maybe financial systems. For those who integrate to M-Pesa, if you are doing B2B, you need to be connected via VPN. This is the subnet where we have all that stuff happening. So if you look at here, I'll just go down and then I'll explain what happens at the top. We have a virtual private gateway over here, at least in these 2 connections. So we have 2 things. We have partner cloud, and we have your on-premise infrastructure. If maybe you're running a hybrid setup, would have your virtual private gateway. You'd have your customer gateway over here. And then at the middle is what we call now a VPN, which is a secure tunnel that you could make. And then we have an external facing load balancer. And what basically this does is route your traffic from here, from the application VPC down to maybe whatever you have. So it's like an egress kind of setup. And then here we have an endpoint, and basically the endpoint is what facilitates communication from your data center or maybe financial services or things connected via the cloud to the other VPC. And then what it does is we have an endpoint over here, an endpoint service running on the other end. We have a network load balancer, and then finally an ingress load balancer that sends your traffic over to this side. So that's an example of a setup that you would use if you wanted to go to set up a hybrid setup or something in the cloud. So the basic reason why we have several things is I'm trying to explain a form of an architecture that is 1, scalable, and 2, secure as the primary considerations that we look at when you're setting up infrastructure on the cloud. So for example, we want to protect everything that is available. We want to make sure that our services run well with minimal risk of being compromised. Our data is not accessible from any unnecessary sources, and external connectivity is safe. So for that reason, we have our ingress load balancer. Even to add an extra layer of security, what people do is they maybe have an API gateway running on top of here that will provide some form of authentication. We have your ingress load balancer using HTTPS. We have your pods running again. They might have some form of authentication, even if it's basic auth. And then again, remember, these are public. So in case of trouble, in case should anything happen and you got compromised, what you just do is maybe disable this peering connection and disable this peering connection. And then the person who is malicious will not be able to access all the other VPCs. So that way you have mitigated the risk. Again, the data that is here is in a different VPC. You have only exposed the ports that are required. You have only exposed it to the VPCs that are required. For example, the external connectivity VPC is not able to connect to this other VPC because they have no business communicating, not unless you had maybe needs to communicate to the database that is on the cloud, that's when you'd allow it to happen. In terms of these, again, you are again using a VPN connection with some strong form of authentication between the same that can hardly be compromised. Then there's other things that is in your application security, like authentication, encryption at rest, in transit, and stuff like that. Yeah, so that's what I had for setup. I don't know whether anybody has a question in regards to this setup before I maybe go to the other points.
Oh, guys, if you have a question, you can post your question in the chat area. Then I'll just I'm taking those questions and we'll respond to them. So just use the chat area to post your questions. Feel free, please. I think Moses, you can proceed. Oh, wait. There's a question. Yes, I have a question. Just post the question. Just write the question in the chat section, please. Brian.
Okay, just a second.
So how do you mitigate downtime on the DB layer? That is the question.
Okay. So I'll answer it right away. I don't know whether the screen is visible or the diagram is visible, right?
Yes.
So different things that you do. First of all, one, downtime is caused by when your data center goes down, right? So maybe if you are hosted in one region, for example, let me just zoom in. If you're hosted in this zone and it goes down, you will have the downtime, right? But if you're set up in the 3 availability zones, what normally happens is AWS has this way of where data is synchronized across the databases, especially if you used managed services. If you use services like if you provision your own MySQL stuff on your own VM, you will be responsible for doing how data is synchronized across the different data centers. But if you used AWS managed services, your data will be synchronized across, and in case of a downtime, the switchover will all be almost seamless. You basically don't even need to change anything. It's just an endpoint that will continue being the same endpoint that you'll be using. I don't know whether I've answered that question. Don't know whether I've answered the question. Oh, yeah. So Brian Wandera?
Sorry, I was muted. So as we wait for Brian to respond, yes, you have, okay. Thank you, Brian. Maybe you can explore a little about option to manually manage. I think we can schedule for that one because I think it's might be lengthy. So the next question is, how do you load balance with an elastic IP? How do you load balance with an elastic IP?
So that I cannot be able to answer immediately on the fly. Something that I'd have to consult, considering that I don't use AWS right now daily. I'd have to consult and maybe give an answer after this.
Okay, so Philip, if you're in the Laravel group, Philip Najo, if you're in the Laravel group, I think Moses will get back to you.
Just ping me on the side, then we can try and experiment. Or maybe come on top and answer.
Okay, or you can PM me. I think that's my Twitter handle. Then we'll share it later on, and we'll share it with the group. The next question is, using the case of DigitalOcean, once you create droplets, you can map with your own domain. About AWS, yeah, I think there's that functionality, but we will talk about connecting domain. Yeah, we'll talk about connecting domain and your VPN in another session. So please, Collins, just hold on. We'll inform you. Yes, you have. That's Brian Juma, route 53. I think you've been answered.
This route 53. That's the answer.
Yeah, that's a fair answer. But we'll talk about it in length, like having even wildcat subdomain, stuff like that.
Yeah.
Which Laravel group I will join? Okay, I'll share the link. How do you do CI/CD? There's a session coming up for CI/CD, so don't worry about that one. There's a session coming in I think 4 weeks on CI/CD, so don't worry,
Can I
don't
say
sweat
something
about it.
about the offerings that AWS has on the
Sure,
CI/CD? Maybe in
sure.
this context.
Okay,
So
sure.
other than setting up, the easiest way or something that somebody would look like is maybe setting up something like a Jenkins cluster. Jenkins or Jenkins X cluster on whatever infrastructure you're running, and use that for CI/CD. The next thing is you could use the code pipeline thing that is set up by that AWS have as an offering, where you could deploy your code, you could do your CI stuff and stuff like that. And also for something, depending on the technology that you choose to deploy, there's things like ECS where you are not able to use things like Jenkins. Oh yeah, GitLab CI. So if you go to with ECS, something like ECS, you're not able to, if you go with something like ECS, you're only able to do continuous deployment with AWS code deploy. But yeah, kuna vitu zingine mmesema hapa, GitLab CI, GitLab CI, GitHub Actions, GitLab CI CD, all those you could integrate to them. But then again, depends on the technology you go with. Yeah.
There's also one for Bitbucket, I'm sure. Okay, so I think you can proceed. I'll check the question and inform you when to answer them. Okay.
All right. So where we're at is we're at. Sorry, my screen is. Okay. Number 2. Cool. Still have this thing over here. So the final thing is the references, and then I'll go to the references which are there. The well-architected framework is a diagram I've shared. The shared responsibility model, again, is a diagram that I've shared before. And then there's a total TCO calculator that is available. There's a link over there. What it basically does, it enables you to to look at the costs, to compare the costs that you're getting right now by running maybe stuff in a co-location space or in an on-premise setup, and compare that with AWS. It can give you a good estimate. But finally, I didn't get quite to prepare these slides, but I'll speak something about various optimizations that you could do to your stuff. If you allow me shortly, I'm just fetching the notes for the same. I'm fetching the notes to that. So here are several tips that you can use to enhance your setup. So point number 1 on security is one, use API gateways. API gateways come in handy. Actually, let me see whether I can get it over here in my notes. I don't know whether this is visible to anyone. So. Sorry.
Kindly mute yourself, please. I think for those who joined, please mute yourself.
So there's several things that you can look at or you can do. I'm trying to get some place whereby there'll be minimal distractions on the side. Just copy this somewhere. Hold on kidogo. You may read through the talk. But one, use your API gateways. They'll help you a lot. You could put some form of authentication over there. could put your throttling, maybe rate limiting over there, and protect your APIs, particularly when you have high traffic and you have denial of service attacks. You could be able to do this with API gateways. Next, protect your APIs with some form of authentication. Next, when you're using Kubernetes, encrypt your secrets at rest. Also, the same thing applies for the data. Encrypt and anonymize your data, especially sensitive data on transit and at rest. This is again mitigation in case a malicious person gains access to your system. You can mitigate what they are able to do. Then the next thing, as you've seen in the diagram, is use multiple VPCs, subnets, and security group to allow only the traffic that is required to come in and out. So again, I think we may explain here, use HTTPS, do not log sensitive information. And again, I repeat, things like passwords, API keys, responses that come from external systems, stuff like that should not be logged. And then, I don't know how Laravel does this, but then you could have, or look into how you could manage, you could have a central place for managing your configs, so that if you want to change them, you could change them well. From an access perspective also, you would also allow the relevant people to access them and stuff like that. Operational efficiencies, look into using pipelines for code. Gone are the days whereby we used to write code and then SSH to a server, maybe do actions on the server, automate those things, free up your mind, focus on doing other things. Focus, again, the next thing in operational efficiency, you could look into infrastructure as code, see how you could you could automate some of your tasks, see how you could provision infrastructure. A case that is very common is maybe somebody accidentally deleting several components of the infrastructure, and the infrastructure just disappearing that way, and you guys taking time to provision it. Have infrastructure as code. Then the next thing, monitor actively and proactively. Notice when stats go down. Notice when your resource usage goes down or goes up. Notice when APIs take long and action them immediately. Then the next thing is set up alerts in case events happen. For example, if you have a VPN connection to a certain place and it goes down, set up events for the same. If you are using services or different microservices, set up health checks. In case a health check does not pass a certain threshold, notify the people. These things are simple. You could use the tools that you have. You could build webhooks on top of Slack, Teams to notify yourself. You could send SMSs if you're lucky enough. The next thing is user and password policies. Come up with good policies that enable users to access only the things that you need and at the right time, and not access a lot of it. Also, make sure that you manage your password well, such that you could have a password policy that the passwords expire at a certain time, so that in case of a breach, you can mitigate a risk that happens. And the next thing is on Kubernetes. Tips that you could do, give access control with tokens. So for example, if I'm a developer working on a certain project that has a certain namespace, give me a token for the namespace that I need. Don't give excessive permissions. And then you could use things like fluentd to configure your logs from the Kubernetes cluster to CloudWatch. Use Istio for the service mesh and further security, so that you can be able to see the traffic that goes in between different pods and services. Also as well be able to even increase your security in the cluster by controlling what and which thing access can be able to talk to your service. The next thing, look into Helm and Helm charts for your deployments. And then finally, as a cost factor for something that I have seen happen across many teams, is people tend to provision many ingress load balancer for different services that we have. And what I'm here to say is, That's not correct. There's a better way and a cost-efficient way in that you could be able to provision one ingress, expose different services in your namespace, and thereby reducing your costs significantly on the cloud. So I think we've come to the end of the talk by me. Maybe if you guys have any questions, finally.
There's a question. On the operation efficiency, what third-party service is best for setting up alerts? I think you can answer that one.
So basically, you could look into Elk, Elasticsearch, Logstash, Kibana, and then you could see how well that goes with this service called Grafana. If you want to do it at a commercial scale, you could check out Splunk.
I think I think AWS also have their own alerting system.
Yeah, again, he said third party. So
oh, sorry. Oh, yeah. Yeah, sorry.
Off the box, you could
go. This one out there. Let me say this one strongly. This session or this virtual meetup was not sponsored by AWS. Okay, it was not sponsored. We can talk about any VPS provider. It was not sponsored by AWS. So guys, don't confuse. So feel free to use Azure, DigitalOcean, Linode, and stuff like that. But we were looking at a production level where if Kardashian decides to treat your application, how will you kind of manage your infrastructure? And AWS is mature in the game. That's why we opted for AWS. So it's not sponsored by AWS by any means. So for our next session, we will still have Moses, if I'm not wrong, and it will be Anton. That is setting the production server. We won't have, of course, we need to start with the theory part and make you understand everything, what it involves, and how to set up a good server. So you need to understand the theory first before we do the answer. So on our next session, which will happen in 2 weeks, we're doing this one bi-weekly. We'll focus on setting up the server ready for production. Please don't miss. I'll share the link again with everyone on various groups, and also encourage other people. It's the same link, by the way, so encourage other people also to join. So this is not based on I'm doing this X language. It's servers for. So thank you so much for attending this virtual meetup, and see you on the next one. Before we go.